Hello and welcome. Here at EcoStruxure Design, we have this core belief. The future isn't something that just happens, it's something you engineer. And in this explainer, we're going to show you exactly how we're redesigning our world from the ground up to be smarter, safer, and way more sustainable. So, let's just start with a big idea. Just imagine for a second, what if the buildings we live in, the bridges we cross, what if they didn't just support us, but actually helped support the health of our entire planet?
All right, here's a quick look at what we're going to cover. We'll start with the big picture, the global infrastructure challenge. Then we'll dive into our mission, our research, how we make a real-world impact, and finally, our vision for a much smarter future.
Okay, so first things first. To really get what we do, you have to understand the problem we're trying to solve. And honestly, the way we've been building our world, well, it's reaching a breaking point. The need for a change isn't just a nice idea, it's absolutely urgent.
Think about it, the very structures that we rely on for modern life are at a major crossroads. We need more and more of them every single year, but the way we've always built things is just consuming resources and energy at a rate that we just can't sustain.
Let's break that down a little. Our buildings and infrastructure, they're responsible for a huge chunk of global carbon emissions. They eat up massive amounts of our planet's finite resources. Plus, if they're not designed and maintained perfectly, they can pose serious safety risks. And the kicker? The global demand for even more construction is just going up and up. This is the challenge we were literally built to solve.
So, how do you even begin to solve a problem on that scale? Well, it takes a totally new way of thinking. And that's really where our mission begins, by completely reimagining engineering from the inside out.
This right here, this is our promise. We bring together experts from a whole bunch of different fields, but we're all laser-focused on one goal: to engineer structures that aren't just sustainable and resilient, but are also smarter and safer over their entire lifetime.
Our method really comes down to three key things. It all starts with a solid foundation of core engineering knowledge. You have to get the fundamentals right, but then we amplify that with some really advanced computational tools. We're talking AI, optimization, the works. And that combination is what lets us achieve our ultimate goal: smart, sustainable results that, frankly, were impossible before.
So when we say computational intelligence, what does that actually mean? I know, it sounds a little like science fiction, but it's not. It's all about using AI and really powerful algorithms to make smarter choices in our designs. It means we can simulate how a bridge will perform over 100 years, or design a skyscraper that uses 30% less concrete. It's about building safety right into the digital DNA of a structure before a single piece of foundation is ever poured.
And this whole approach is what fuels our research. It's where we get to have fun and constantly push the boundaries of what's even possible in structural design.
This really shows you the huge shift we're making. The traditional model, it's pretty static, it's resource-heavy. Our intelligent model is dynamic, it's data-driven. So instead of reacting after something fails, our designs are proactive. They're resilient and optimized for peak performance right from day one. It's a total game changer.
So what does this actually look like in practice? Well, our core research areas are where all this innovation happens. We're using machine learning to predict how a building might behave in an earthquake years before one ever hits. We're calculating a structure's entire environmental footprint from cradle to grave. We're using risk-informed engineering to spot potential failures before they can ever happen, and we're developing these incredible optimization frameworks to make massive structures like long-span bridges safer and way more efficient than ever before.
But theory is only half the story. All the research in the world doesn't mean much if it stays in a lab. We are absolutely driven to turn our research into tangible, real-world impact.
This is so central to our whole philosophy. We love living at that exciting intersection where academic discovery meets practical, real-world needs. Our job is to bridge that gap and turn groundbreaking research into solutions that people can actually use.
And we definitely don't do it alone. We team up with leaders in academia, in industry, and in the public sector. This network is what lets us test our theories on real projects, making sure our innovations aren't just cool ideas, but are practical and ready to go. So what are the bottom line benefits here? Well, our approach really delivers across the board. By optimizing every resource, we lower project costs. By designing smarter, we dramatically reduce the environmental impact. And by building in resilience from the very start, we create safer, more durable structures for the long haul. It's just better for the budget, better for the planet, and better for people. It's a win-win-win.
All of this work, every project, every line of code, is all aimed at one single, really ambitious goal: building a fundamentally smarter future for everyone. This is our ultimate why. We truly believe that engineering's greatest challenge today is to serve both humanity and the planet we call home, and all of our work is dedicated to proving that we don't have to choose between progress and preservation. We can engineer a future that achieves both.
And that brings us to one final forward-looking question. And really, this isn't just a question for us, it's for all of us. As we look to the future, the challenge and the opportunity are crystal clear. How are we, together, going to shape the resilient, sustainable, and truly intelligent cities of tomorrow?